Okay, so example 4, we're asked to find g prime of x, but you have to be careful. We're asked to find g of prime of x and then use it to find the slope of the graph g at the slope at the points 3, 2, and 0, 1. So we have to find the derivative first, and once we have the derivative, then we move on to use that derivative to find those values. So let's get started. I'm going to do g prime of x is equal to the limit of, and I think I'm going to use h this time just so you've seen the variation, h as h approaches 0 instead of delta x. And I'm going to then find a g of x plus h minus g of x over h instead of writing delta x. So if I'm substituting in, I get the limit as h approaches 0 of wherever I see the x, I'm now putting in x plus h. So that's going to give me a square root of x plus h plus 1, because I'm replacing the x by x plus h, like that. I highlighted that. And then minus g of x, which is just x plus 1 over h. If I substituted in 0 for h right now, I'd get indeterminate form. It would be 0 over 0. So our answer to that is to use, when we have radicals, I can't really factor, I can't do anything but use the conjugates. So I'm going to multiply the numerator and the denominator by the conjugate of the numerator. There we go. Whoops, horrible handwriting. Sorry about that. And then in the numerator, just be really careful. It might be a good idea to put in a parenthesis for this. In the numerator, a lot of people mess up forgetting to distribute the negative, and that will give you the wrong answer. So we end up with x plus h plus 1 minus, in parentheses, x plus 1. Like that. Because for some reason, people actually mainly go wrong in this part, this negative, they forget to distribute. So now we have to remember also to have the entire denominator. I tend to sometimes, I think I'm going to move over the h a little bit here. We have to remember the h and then times the square root of x plus h plus 1 plus the square root of x plus 1 in the denominator. And then when we distribute the negative up there, maybe we can cancel some things out. So I'll tell you, you can with a little wink here. Oh, it's going to be x plus h plus 1 minus x minus 1. That's where a lot of people go wrong. And then times h over h times all of that business down here in the denominator. So let's not forget to write all of that. There we go. And then we have some cancellation. The positive x and the negative x, the positive 1 and the negative 1. And on top of everything else, if I just look at this part, the h over h, they also cancel each other out. So let's write that a little more cleanly. We get the limit. Oh, I meant to use purple there. Purple is equal to the limit as h approaches 0 of the h's cancel out. So that leaves me just with a 1 in the numerator. And then we have the square root of x plus h plus 1 plus the square root of x plus 1. And now I'm going to apply the limit. So applying the limit only applies to the h. So that gives me in the denominator. And now once, by the way, once I've taken the limit, do not write the limit anymore. I'm seeing that people are almost overwriting the limit or underwriting. They're not writing limit in front until they, like to the end, or they write limits once they've taken it. And you can't do that either. So we get the square root of x plus 1 plus the square root of x plus 1. But those are like terms. So just to simplify a bit, that's going to give me, let's write this cleanly down here on the bottom. G, and I wrote f for some reason. G prime of x is equal to 1 over those two like terms in the denominator becomes 2 times the square root of x plus 1. Now, I'm not completely done because it's asking you to find g prime of x at points 3, 2 and 0, 1. So I'm picking a different color here at, I'm going to make it explicit, 3, 2, g prime of x. I have to take it of the x, which is 3, is equal to 1 over 2 times the square root of 3 plus 1. So that simplifies to 1 over, let's see, it would be a 4, like that. So that's the one piece. And then we also want to find it at, what was it, 0, 1? Okay, let's try that. So that's a g prime at 0. It's the x we're substituting in to find this. Is going to give me 1 over 2 times the square root of 0 plus 1. On the AP exam, by the way, free response, you could just stop there. But for our purposes, we're going to simplify, so we get 1 over 2. And that's part A. Now I want you to try and find the answer to part B. And I'm going to hit the pause button, and so should you. And I'll put the answer in for you. So part B was a little bit tricky just in the end. I think the work itself was easy. Compared to or easier compared to the other one. However, down here at one of the points, it ends up being undefined. And that's something we end up discussing a lot later. It happens at an endpoint, and there are no derivatives at an endpoint of a function. So therefore, there is no derivative that exists there. It could be, by the way, it could be a vertical asymptote, but in this case, it's not. Okay, so for our example 5a, slightly different. We could use a little bit of a different notation in this case. For us, I think we're going to go in with, first of all, I want you to notice that the independent variable is the letter t and not the letter x. That matters. You can't all of a sudden switch to the letter x. I tend to, by rote, I kind of just always put in an x, but I really have to pay attention in problems like this. We're going to either, you could use y prime, or we could use the notation dy dx, or dy, see I even said it, dy dt in this case, like that. So that's what I think I'll go with. We're taking the limit. And by the way, you could use f prime or something, but if you are going to do that, you would have to write let f of x equal y somewhere on the problem so that you could write the prime notation, or you could just write y prime. But just for practice here, we're going to write dy dt in this case. It's going to be the limit, and instead of delta x, it's going to be delta t approaching 0. So that means we end up with a -3, I almost said 1, -3 over t plus delta t minus -3 over t divided by delta t. And I could have used h here as well if I'd like. Limit, so it's equal to the limit as delta t approaches 0. I'm going to do a little bit of simplification. It's going to give me -3 over t plus delta t plus 3 over t and then delta t over delta t, like so. So right now, there's a couple of ways you could do this. One way is that you could view the denominator as delta t over 1, and then take multiply the numerator by the reciprocal of the denominator, because you have a fraction or fractions divided by another fraction, and that means you can multiply by the reciprocal. That is one way to do it. Another way is just to simplify a complex rational expression by multiplying the numerator and the denominator by the common denominator of the smaller fractions. So I suggest you do this here, because then you don't have to get a common denominator later and try and simplify it. So this, to me, seems the simplest. But again, it's one of those stylistic things. If you watch any other videos online, or if you look in the book, they might do something different. We are going to multiply the numerator and the denominator by the least common denominator of the smaller fractions. In this case, it's going to be t times t plus delta t. And I have to remember to do that in both places. T plus a delta t, like so. And that is going to give me equals the limit as delta t approaches 0. In the numerator, I'm distributing t times t plus delta t. The first term is going to give me -3 times just the t plus 3 times, now it's going to be t plus delta t because the t's cancel out. And in the denominator, I have all of that mess. I have the delta t that's already there times the t times t plus a delta t. Don't worry, this all simplifies in a little bit. And now we're going to just distribute in the numerator, simplify a bit where we can. In the numerator, I get negative 3t plus 3t plus 3 delta t over, and I'm just going to leave this down here because hopefully I can get some simplification out of it. T times t plus delta t, like so, like that. And then I'm going to go in and cancel. I see that in the numerator we have negative 3t and positive 3t. They both cancel out. And then I notice this. We have in the numerator, I just have 3 times delta t. And in the denominator, we also have a factor delta t. That means I can cancel those out like that. But you can't do that until you've gotten rid of the other terms. Just be careful, or else you have to factor out the delta t first. I am left with, let's simplify this a bit, a 3 in the numerator and a t times t plus a delta t in the denominator. And now I'm going to simplify this by, or evaluate this by applying the limit. So that means I end up with 3 over t times t in the denominator. And now I have applied the limit. I should not write it anymore, even though there are variables in it, because the limit only applies to delta t. So in this case, let's write it nice and neat. dy dt is equal to 3 over t squared. And I'm just going to reread the directions to make sure I didn't forget anything. Okay, let me see. No, I'm not supposed to find the value anywhere, so we're good to go. Now I want you to try B. We're going to pause it, and I'm going to put the answer up for B. So here's the answer for part B. Now we've tried lots of different types. The next step is for you to practice a bunch. That's why we have the homework and all of those worksheets I've made or found.